Good morning, Year 10. Hopefully you've had a decent half term. What we're going to move on to, we started ecology and looked at feeding relationships and the food webs and how those animals in the community interdepend on each other. What I would suggest you do now quickly is just pause, because when I'm using words like ecosystem or community or population, I need you to know what they mean. Now, what you should have done already is you should have recorded those keywords in your glossary. So if you pause just for 30 seconds and have a quick look at your book and your glossary, just make sure you're familiar with the key terms. Okay, so in reality, sometimes the number of an organism, the population of an organism, will stay fairly constant. However, what we find is a predator-prey cycle. So when there's lots of your prey available, if you're a predator, then because you've got more food to eat, your numbers will increase. But as your numbers increase, the problem then is that there's more of you as a predator, and therefore your prey goes down. So just watch the following short video, but then at the end of that, I want you to be able to describe the predator-prey cycle in your own words. Within any environment, there are different species living there, and this is the community, all the living organisms and that live in the same place and interdepend on each other. In this example, the evil Zuzu pet is the predator. The poor Care Bears are the prey.
Roar!
Oh no, one's been eaten. Look how sad the parents look. When the number of predators, the Zuzu pets, are high, they will eat lots of Care Bears. And so the number of prey goes down. Unfortunately, that means there isn't much prey to eat, so now the Zuzu pets haven't got enough food, so they don't reproduce so much, so their number goes down. Because the number of predators has gone down, then there aren't so many there eating the prey, so they reproduce more quickly and their number goes up. Ooh. Now there's lots of prey available, then that means that the number of Zuzu pets will now start to go up. And the whole cycle starts again. Because there's many predators, they'll eat lots of the prey. This continuing changing of the numbers of the Zuzu pets, the predators and the prey, is called a predator-prey cycle. So you can't just take an estimate of the numbers of a population at one time, you have to take it over a long time, otherwise you might think something's going wrong with the population. Okay, so for the example I just used, if I first of all go along the lines of, there's not many predators around, so there's not many Zuzu pets around, therefore the number of Care Bears starts to rise. Now, because there's more Care Bears around all of a sudden, now the number of Zuzu pets starts to rise as well. That blue line is showing the Zuzu pets, the predator. The yellow line showing the prey, the Care Bear. Now though, because here there's now quite a lot of predators around, that means more of these are going to be eaten and the number starts to go down. Now unfortunately for the Zuzu pet, now the numbers go down as well. But here there's not many predators, so all of a sudden, same as before, the number of Zuzu pets starts to increase. And therefore more food available, so the number of predators starts to increase again. More predators, the number of Zuzu pets goes down. Now, my example with using the My Toys I had available is a little bit silly. Or, unless you want to believe that, and then actually you can use that as a real example. So, these two animals, and the reason I'm showing you pictures of them are, this here animal is called a snowshoe hare, living up north, not in this country, but in North America, and this is the lynx. Both animals were hunted for their fur over a long period of times, and so because of this, a lot of data was available. And Charles Elton, with the Hudson Bay Company, who were using the skins and the furs of the animals, actually managed to have 100 years worth of data. Now, that's a lot more complicated than the graph I've just drawn, but it's the same idea. What they found is, over that nearly 100-year period, there was large fluctuations. So here, for example, there are loads of hares, massive population, and that's followed soon after by this spike, this growth here in lynxes. But then obviously there's quite a few lynxes around at this point here. I've just put in blue, and therefore the snowshoe hares goes down. And if you look across here, they peak together. They peak fairly similar together. So when there's lots of prey around, the predator goes up. But because the predator goes up, there's not much prey. And I think I've probably explained this enough times already. Okay. Now, in the population, I'm just going to put this on here for you. 1 second. So it's all there. Could you now pause and then, using what's on the screen in front of you, don't just copy it, either for snowshoes, hares and lynxes, or for Zuzu pets and Care Bears, with some drawings, obviously, could you explain, and a graph, I'd like you to maybe go back a couple of minutes, draw out a sample graph of the predator-prey cycle, and then go through and just explain the reasons for it. I think I've explained it 3 or 4 times already. Okay, I'll give you a few minutes to do that. Okay, welcome back. So, your graph could look something like this, or the ones I've shown similar before. It's not just there are other factors that can affect the size of a population. One of them would be, for example, the introduction of a new predator. So in this case, the giant eagle now eating Care Bears means there aren't as many Care Bears for the Zuzu pets, so therefore their number would be affected. Another factor that can affect the number in a population, for example, would be the effect of people. Not just using up habitats, etc., but things like overhunting. Oh no, the dwarves are overhunting the Care Bears. That obviously means there's less food to eat, so therefore the number of Zuzu pets goes down. Populations can also be affected by things like new diseases. So for example, the Zuzu pets getting a new disease could possibly wipe a population out, but then the number of Care Bears would increase. It's not just predator and prey that will affect it. So again, very short video starting now. And so hopefully what you'll see is there's other things. So if there's a lot of food around, obviously the birth rate goes up if you're a predator. If there's lots of you dying, the population number goes down. Competition we haven't really looked at yet, but I'm going to go on to that in a minute. The availability of food. Obviously the prey that you're going to eat, the more there's available, like with the Care Bears, etc., the more you'll have. The predators that are around, if there's a disease in the population, obviously that will affect your numbers. Something I haven't mentioned yet, if you have parasites, so parasites living on you, living in your gut, living on an organism, draining some of the food, it means it's not going to live as long necessarily. It's not going to have as much energy for reproduction and passing on the food, because other creatures such as fleas, tapeworms, different parasites that live in the blood of animals, etc., or parasites who feed off plants, stealing away some of their materials, stealing away some of the leaf surface area, etc. And obviously your space or your territory, so animals competing with each other for where they live. And then you've got some animals move from one place to another, emigration and immigration, moving out of an area, moving into an area. So some animals migrate seasonally. So for some of our birds in this country, some species migrate here in winter, and actually they form, they're in competition with our birds who are here all year round, but maybe just during the winter, and then during the summer they're not competing. And as I said, with competition, you can have it between members of the same species or between different species. So in the two photos here, red squirrels are competing with each other. If there's a forest with red squirrels in it, the red squirrels all want the food. They want the space, they want the territory, so they're actually in competition with each other. The weaker ones will die out, the more successful ones will continue. But we'll talk more about that when we get to evolution. But also there's competition between species, as in this little video again. So, could you now make sure you've got some of the other factors listed from what we just said? So what can affect, so if you put a little title, what can affect the size of a population, if you then make a list of things and you include competition, diseases, space, territory, parasites, the amount of food available, predators around, the prey that's available. So maybe go back a couple of minutes and use that list and just add a little bit of detail for each one. That would be brilliant. Thank you.